Hey everyone, today we're going to discuss about inverse functions. Now, if f is a one-to-one function, then the inverse of f, denoted by f raised to negative 1, is the function formed by reversing all the ordered pairs in f. Thus, the inverse of f is the set of ordered pairs yx such that xy is in f. So basically, whenever we talk about inverse functions, we just switch the values of x and y. For example, if we have a function 1, 2, 3, 4, and 5, 6, then their inverse is, we just flip the x and the y. So this becomes 2, 1, 4, 3, and 6, 5. So we just flip the x and the y to get the inverse of the function. Now, let's go to the properties of the inverse function. Number 1, the inverse f is a one-to-one function and f is also one-to-one. It is a requirement that the function that we're dealing with is a one-to-one function so that when we get its inverse, it would also be a one-to-one function. If ever that the function is not one-to-one, then the inverse would not be a function. Now, the second property of the inverse function is that the domain of the inverse function is equal to the range of the function, since the x and y are flipped. And the range of the inverse function is the domain of the function itself. Now, let's try to solve for the inverse of a function. So we have here a function f of x is equal to 3x plus 2. Now let's try to identify the equation of the inverse of this function. Now to solve for the inverse function, we replace f of x with y. Then we interchange x and y, then solve for the new y from the equation. After solving, we replace the new y with inverse function of f if the inverse is a function. So let's have it in this one. F of x is equal to 3x plus 2. So first we replace the f of x with y. So y is equal to 3x plus 2. After that, let us reverse the y and the x. So this becomes x is equal to 3y plus 2. We reverse it since that what we're going to get is the inverse of the function. So we just replace the x and the y. Then from here, we are going to solve for the y of this function. So we have to isolate the y on one side of the equation. So in this case, let's try to isolate y on the right side. Then let's flip the equation afterwards. So let's get this 2 here and transpose it to the other side. So this now becomes x minus 2 is equal to 3y. Now, what we're left with is 3. So we divide both sides by 3. Cancelling this out, or dividing rather, what we get is x minus 2 all over 3 is equal to y. We flip the left and the right side so that the y would be on the left side. So this becomes y is equal to x minus 2 all over 3. Since we're able to solve for the value of y now, let's replace y with inverse f of x. So this now becomes f raised to the negative 1 of x is equal to x minus 2 all over 3. Therefore, the inverse of f of x is equal to 3x plus 2 is inverse f of x is equal to x minus 2 all over 3. That's how we obtain the inverse of a function. Let's have another example. Let's have g of x is equal to 2x plus 1 all over 3x minus 5. So let's get the inverse of this rational function. So first off, let's replace the g of x as y. So this is now y is equal to 2x plus 1 all over 3x minus 5. After that, let's replace x and y. So this now becomes x equals 2y plus 1 all over 3y minus 5. Normally, I would indicate an arrow here to indicate that this has been flipped already, but this is not a necessity. It's just an option that you can choose to have. Now, since we're going to solve for y here, what we're going to do is we are going to multiply both sides by the denominator so that we get to cancel the denominator. So multiply both sides by 3y minus 5. And do it the same thing here. So they get divided. We're left with x times 3y minus 5 is equal to 2y plus 1. Our goal here is to get the y to either the left or the right side. Earlier, we put the y to the right side, but it's much easier. This time, let's try putting the y on the left side. So we have an x here. We distribute the x to the binomial. So distribute. What we're going to get is 3xy minus 5x is equal to 2y plus 1. Now, this term has a value of y, so we put it on the left side. And this term doesn't have a y, so we put it on the right side. So that's what we're going to do. We're going to do two transpositions. So this will become 3xy minus 2y is equal to 5x plus 1. So the 5x will transpose, the negative becomes positive, and the 2y is positive, transpose, it becomes negative. So 3xy minus 2y is equal to 5x plus 1. Since there is, in this left side, both terms have y, right? So what we're going to do is we're going to factor them out. So let's factor it out. We'll have y, then what's left is 3x minus 2 is equal to 5x plus 1. So y is isolated here, and the binomial that we just factored doesn't contain any y. So what we're going to do is we are going to divide both sides by 3x minus 2 so that y will be left on the left side. So they get divided. We're left with y is equal to 5x plus 1 all over 3x minus 2. So we're able to isolate the y, and this right side here doesn't contain any y. So this is the inverse already. So let's replace y with inverse g of x is equal to 5x plus 1 all over 3x minus 2. So this is the inverse of g of x. So that's how we go around in solving for the inverse of a function. Now for our next video, we're going to discuss on how to graph an inverse function. So thank you for watching. I hope you learned a lot today, and see you guys on the next video.